So just like when we were factoring, a equals to 1 and a not equals to 1 is a big deal with completing the square too. So we're going to start off with an example where a equals 1, because that's going to be a little easier for us to deal with. So let's take a look at what I have here on paper. I also want to show you a couple things that you can't do. So here's an equation. Here's an equation. So our examples here are, I'm going to write some procedures down on the side here, but our example here for completing the square where a equals 1 is 0 equals x squared minus 10x plus 6. So if we wanted to try to solve this, we would typically start by factoring. So if we try to factor, with two binomials, we need two things that multiply to 6 that add to negative 10. They don't exist. 6 and 1 won't, 2 and 3 won't. There are no other options. So we can't factor it. So that's out the window. So maybe you want to try this. Maybe you want to subtract 6. Minus 6 equals x squared minus 10x. And then maybe you want to try to factor this, like x times x minus 10 equals negative 6. Now, remember, we've gotten to situations like this before, and we use zero product property. But this needs to be 0, and this is not 0. So we can't go about this way. This won't work. So our procedure is going to be to complete the square. So let's see how we do that. The first thing we need to do, just like we did here, is we need to isolate x squared minus x squared plus bx. So let's move the 6 to the other side. Now, their teachers teach us different ways. This is the way I like to teach it. I think it's clear this way. You could do things a little differently as how you deal with a 6, but this is what I like to do. So isolate this part by moving the 6 to the other side. So we get negative 6 equals x squared minus 10x. Now, this term here is not a perfect square. So this is where we quote unquote complete the square. All right. So if this were a perfect square, it would have a certain number here. All right. That number is half of that squared. All right. Half of that squared. Half of that squared is 25. Now, if I add 25 to this side, I have to add it to the other side also. All right. So I balance the equation. Now let's see why we chose that 25. Notice that this side is a perfect square trinomial, which can be factored. It factors to x minus 5 squared. All right. If we had x minus 5 here, you would need a 25 here for this to work. So that's the completing the square part. All right. So then we factor it. Now the other side, we're just going to simplify. So negative 6 plus 25 is plus 19, positive 19. Okay. Now we're in a position where we can go ahead and solve this, because here, when we started off, we had x's in two different positions where we couldn't get them together because they're not like terms. Here, we only have an x in one position, so we can manipulate this equation so that we get down to x. Next thing we're going to do is we're going to take the square root of both sides. So we have square root of 19, which of course is not a pretty number, equals negative 5. Now, when we take the square root of both sides, we always wind up with plus or minus, right? When we take the square root of both sides. And that's really because this winds up an absolute value, but we forget about that very quickly, that this is an absolute value, and we have to take plus or minus over there. We just take the square root, and we wind up with plus or minus on both sides. And then we have to add the 5. So we wind up with x equals 5 plus root 19, or 5 minus root 19. Right? And we've solved our equation. This, in fact, because our equation was set equal to 0 to start with, this, in fact, are the roots, the x-intercepts of this equation. The other thing to note from this equation is this 5 is also the x value of the vertex. Notice it winds up right there. Right, the x value of the vertex, this vertex form, that's the h value of the vertex. So the x value of the vertex winds up from the beginning to be negative b over 2a. All right, something we also talked about in one of the opening videos. All right, so completing the square. Isolate x squared and x. Move the constant to the other side. That's the way I like to do it. Then complete the square. Find the number that completes the square. And that number is going to be b divided by 2 squared. Notice I took negative 10, divided it by 2, and got negative 5, and squared it to get 25, okay? So this number is b divided by 2 squared. All right, add that number to both sides of the equation, okay? Factor the perfect square trinomial. Simplify the other side. All right, if you're solving an equation, you're going to take the square root. Don't forget plus or minus. And then get rid of the 5 to isolate the x. All right. If from here you're looking to put it into vertex form, you would actually have had a y to begin with there. I'll do that in the next example. Okay.